Hello, so today we're going to be talking about implicit differentiation. So, when you're given a function, it can be written in two forms, right? So y equals 1 over x is the explicit way, where y is explicitly defined as a function of x. But this same equation can be written as xy equals 1, and that's the implicit way, right? So of course in this equation you can find y explicitly by just dividing by x, right? But equations can get harder, right? So like let's say you're given the equation x squared plus 3x cubed plus y cubed minus 2y squared plus y equals 6, right? There's no really way to find y in an explicit way in terms of x, right? So in situations like this, we'll use implicit differentiation. So basically what implicit differentiation states is that y is a function, so anytime we take the derivative of y, you have to have a dy dx afterwards, right? So here, let's just write out another equation. X plus y cubed minus y squared equals 6, right? So to use implicit differentiation on this, you have to take the derivative of both sides, right? So this is the same as 1 plus 3y squared dy dx minus 2y dy dx equals 0, because the derivative of 6 is a constant. So basically, so to get like the dy dx, right, all what I did was you take the derivative of this y cubed, and since y is a function, right, so the derivative of anything cubed is 3 times the function squared, right? So then it's 3y squared times the derivative of y, right? And then now this isn't the entire thing, right? Now you need to solve for dy dx, right? So negative 1 equals 3y squared. Dy dx is the same as y prime minus 2y y prime. You can factor out a y prime. So y prime times 3y squared minus 2y equals negative 1. And then y prime equals negative 1 over 3y squared minus 2y. And then that's your answer, right? So now that we have one example of implicit differentiation, let's go on to a textbook problem. Right, so if you have the following book, Calculus of a Single Variable 10E, you could probably find it online, right? I'm going to be on page 145, and let's just work through the first two problems, right? So the first problem is x squared plus y squared equals 9. Here I'm going to use a different marker color. Right, so, and we need to find the derivative by implicit differentiation, right? So the first thing that you would do is take the derivative of both sides, right? So 2x plus 2y y prime equals 0. Again, notice how there's a y prime for every time that I take the derivative of y, right? You move the 2x onto that side. So 2y y prime equals negative 2x, divide by 2y on both sides, right? So the 2's would cancel out, and then you'd be left with y prime equals negative x over y. So moving on to the next question. It's x squared minus y squared equals 25. Again, we're on page 145, 2.5. And then, so the same thing, so 2x minus 2y, y prime equals 0. Negative 2x equals negative 2y, y prime. So the negative 2's cancel out, and then x over y equals y prime. Fairly simple thing. So here. Now, let's move on to question number 21, because 21 is actually a different type of question. It's asking you to evaluate the derivative at a point, right? So back to black marker. So it says xy equals 6 at negative 6, negative 1, right? So first thing that we need to do is take the derivative of both sides, right? So then you get y, the derivative of x, plus the derivative of y, y prime, times x equals 0. So then you can move the negative y equals y prime times x, because we subtracted y from both sides, divide. So negative y over x equals y prime. And now you just have to plug this in, right? So y prime equals negative of negative 1 over negative 6, which equals negative 1 over 6. Because both of those become positive, right? So here, we'll do another one of these problems. Here, let's move on to a more complicated problem. Not that it gets much harder than this. Yeah, here, let's do this one. Number 25. X plus y cubed equals x cubed plus y cubed. So notice how this side isn't a constant anymore. So like you actually have to take the derivative of both sides, right? So this is a simple chain rule. It'd be 3 times x plus y whole squared times the derivative of the inside, 1 plus y prime, right? Equals 3x squared plus 3y squared y prime, right? And now subtract. So this is the same as 3y prime times x plus y squared plus 1 times 3 times x plus y squared equals 3x squared plus 3y squared y prime. So get all the y primes on one side and then all the x's, non-y primes on the other side, right? So then you get 3y prime times x plus y whole squared minus 3y squared y prime equals 3x squared minus 3 times x plus y whole squared. Oh yeah, I forgot to write down at what point. The point is negative 1, 1. Right? So from here, you can factor out 3y prime. Not even, you can just factor out y prime from both sides. All the 3's would cancel. This is the same as y prime times x plus y whole squared minus y squared equals x squared minus x plus y squared. And then you just divide both sides by this, and then you get prime equals x squared minus x plus y whole squared over x plus y whole squared minus y squared. Right? And now we just need to plug it back in. So then you get -1 whole squared minus -1 plus 1 whole squared over -1 plus 1 whole squared minus 1 whole squared. Because that evaluates to 0, so then 1 over -1, which equals -1. Right? And then, so that's how you would do that. So, somebody asked me to evaluate on how to use implicit differentiation on trigonometric functions. And so I'll just do a quick problem on that. I don't really want to look through the book to find one, so I'll just make a problem for myself. Just finding dy dx, not evaluating at a point. So here, let's say that the equation is x squared minus sine y squared plus y to the second equals 16. Right? It would equal like some number. I'm not sure if this would work, but regardless, so first thing that you do, right, is you take the derivative of this, right? So 2x minus the derivative of sine is cos y squared. The derivative of y squared is 2y y prime plus 2y y prime equals 0. Right, so then you move the 2x onto that side. And you get -2x equals negative cos y squared 2y y prime plus 2y y prime. You factor out a y prime from both of these. -2x equals y prime times negative cos y squared 2y plus 2y, right? And then you just divide out by this value, and then you get y prime equals -2x over 2y minus cos of y squared 2y. And then you could factor out a 2y, but I don't think that makes a difference. So then that's how you would do that.